Hey guys, today I'm going to be talking about software architectures and what is the best kind of software architecture for what you want to build. So let's get right into it. So, if we look at your own kind of software, like if you're building like a full stack application, what you would be typically doing is you would be like breaking it down into certain parts. Like even if you have a Next.js application, right, you would have your front end, which is probably like your React or your Vue.js, Svelte, whatever 50 other web frameworks that we have today and more counting as I speak this sentence. And then we have our backend or our API layer, which would be now for Next.js and Nuxt and stuff like that. They have it right in there, or you could even have like a separate backend layer, which is like, a Python backend made in like Flask, Fast API, Django, whatever it might be, C Sharp, .NET. And then you have your database, which could range from being like a Postgres or MySQL all the way to being just simple files on an S3 bucket, right? So these are three components that are mainly there. Now people might say, oh, what about a caching layer that you have with like Redis, or a queue layer, like a message queue, like RabbitMQ or something like that? That could be a different layer. Well, screw you guys. But no, what it would be is those also come into a database sort of format. So, anyway, as we want to simplify the scope of what we want to talk about, these are basically the main three components that you would be seeing in a full stack application. And what software architectures basically highlight is not the development process, but rather the deployment process. So, how do you get this stuff up and running when you are deploying the application onto a server or however you want it to be? So there are three different kinds of software architectures, right? And that would be monolithic, two-tier, and three-tier applications, right? So, in order to understand what these software architectures could mean and what it could mean for your application that you want to deploy, let's first get into what scaling really means. All right. So we have different kind of scaling methods. Okay. And one would be vertical scaling, horizontal scaling, vertical and horizontal scaling. All right. So let's get into the first one, vertical scaling. So imagine if you have deployed your application onto a particular server, whatever it might be. And now the number of people who use your service will now keep increasing. Now, the problem with that is that as the number of users increase, the amount of CPU and RAM that gets used up by your VPS, which is your server, starts increasing. And at a certain point, it could just crash because it's just overloaded with requests. So, what do you do? So, this is where vertical scaling comes into play, where you just simply, you know, uh, increase the kind of resources that are delegated to your server. So let's say you have a $5 VPS that would be like it would be like one vCPU and 2 GB of RAM. It might be sustainable for a couple thousand users, and depending on the kind of thing that you have, like the kind of backend that you have. If it's Python, it's not really memory efficient. If you have something like Go or Rust, it's very memory efficient, so you'll be able to serve a lot more users accordingly. But at a certain point, you're going to reach a bottleneck, and at that point, what you want to do is you want to scale it up. So you'll go from a $5 to maybe say a $10, which would be like two vCPUs and a 4 GB RAM, right? And maybe you want to even add like an EBS, an elastic block storage, right? Where you're just adding like a couple GBs on top of that, which will actually add on because you're adding it onto your compute. The price is actually kind of balloon up, which is what I talk about over here. In the beginning, it's gonna be kind of a linear ramp up, but then after a certain point, getting to a really large server is going to cost a lot of money, especially for just the average person. I'm not talking about enterprise level, because at that point, um, you know, going to that next level really does not matter as much. But it is simple to implement, just simply adding one more server, just changing the configuration. It's very simple. Costs are also very predictable because you have it right there. And also, the thing about vertical scaling is that it is region specific. So wherever you have hosted your server, may it be like Tokyo, Mumbai, Frankfurt, wherever it might be, it's gonna be only in that place that you can only scale it in, because that's where the server resides. You're changing the configuration of that particular server. So that is vertical scaling. Then we have horizontal scaling. So the way horizontal scaling works is that you have a $5 VPS that you've now deployed the application on. And now, like before, the number of users just balloon up and the requests get overloaded. So now how are you going to handle scaling with horizontal scaling? What we would do is we would spin up a separate $5 server. So it's not going to be the same server that we're increasing like with vertical scaling. We're going to create a separate server alongside that, which will handle the influx of users. This is typically lower cost, which is why people prefer this. Cost also linearly increases because you're just increasing the number of services. So let's say you have a $5 VPS, you're opening another one, it's going to be $10, another one more $5, it's going to be $5 every single time. Whereas for vertical scaling, if you were to increase the block storage, it's just going to be like an immediate, like a weird exponential increase. It's not going to be the same kind of increase in prices. And but the thing is that this is not easy to implement. Like how in vertical scaling we could just simply change the server configuration. Over here, you're creating a complete different server. So how are you going to handle traffic to be assigned to one person versus another person? You would have to do like load balancing and create a CI process. For vertical scaling, it's not really that important. Horizontal scaling, you can get away with it, but the thing is that it is a lot more trouble than it's worth. So it's better to set up a CD process right before that. So you would have to set up like an auto deployment process. Um, Horizontal scaling, you only pay for what you use, but that's also the same case for vertical scaling. But the thing is that for vertical scaling, you can't. There's not really a provision to scale down to zero. But over here, you do. You can do stuff like that. But okay, pricing is unpredictable, especially with modern horizontal scaling things. It is unpredictable, but it is region agnostic. So now you imagine you have your server set up in like EU Central, right? And now you can put one in US North or wherever it might be, like a Virginia server. You can actually do that and have the load balancer actually take care of which user should use what server based on where they live. So you'll actually get like a better round trip time when it comes to requests. So that's the cool thing about horizontal scaling. Once you get it set up, it's pretty painless. But yeah, there's pros and cons about having vertical versus horizontal scaling. And with a lot of what serverless has nowadays, with a lot of like, even like serverless databases like Torso and stuff, they all use horizontal scaling simply because of the kind of flexibility that you get with it. But now you even have vertical and horizontal scaling, which is basically the best of both worlds. So we get the large compute per server with vertical, and you get the flexibility of scaling into multiple regions with horizontal. This, however, is the hardest to implement because you have to, at a certain point, there is no option. At least with horizontal scaling, you can at least like set up a server yourself. Vertical and horizontal scaling is something that has to be automated, because if you are not going to, it's pretty much going to be a Herculean and not at all worth its task to do manually. And this is usually used by enterprises. So each company would have to implement it differently based on their needs. Like, at what point do they want to increase their individual server allocation of resources versus creating a separate server, right? At what point do you want to create a horizontal scale, or at what point do you want to vertically scale? So these things have to be like manually tuned for each use case. For at least for horizontal and for vertical scaling alone, you're gonna have that you're going to have some level of standardization. Vertical and horizontal scaling is not really going to have that. Now that we have this basic info of what these things are, let's go into certain services like or certain software architectures, which is monolithic, two tier, and three tier. So a monolithic application looks kind of like this, right? You have a server, right? And then you will have the front end, all three components, right? The front end, back end, and the database all on one single server. The cool thing about having a monolithic application is that, you know, it's all in one place. So it's extremely, the mental model is very simple to understand. You really don't have to worry about really too much. You're just deploying it. Maybe you have like a Docker compose. You're gonna go into the server, SSH into it, and then you're gonna like pull your repo and then just build the Docker application and run it, like multiple Docker files, because you're going to have separate front end, back end, and database. So you're going to have separate things. Round trip time is less because everything is in one place, unlike the other software architectures that we're going to see soon. Everything is just in the same server, so it's going to have pretty much the same round trip time as you would see while you're developing your application. So it's very simple to take care of. However, deployment is difficult, especially continuous deployment. If you want to have some kind of auto deployment, it is going to be fairly difficult, because one thing that you have to remember is, uh, even if your front end and back end are completely stateless, meaning that they do not hold any kind of user data or something like that, and you're keeping that completely within the database is on the same server that has to be changed. So if you make any code changes to your front end or your back end, everything has to be deployed together into the same server. So trying to keep the database consistent while you change the front end and back end is going to be quite challenging, because you can run into a bunch of problems. So people usually write shell scripts, stuff like that, that'll kind of like remove it. But again, it is extremely fragile. And wanting to like, what if you want to like do a migration from, like, you want to change the backend from like Python to Go or something like that, or TypeScript to Go, or Go to TypeScript, something, anything like that. It's going to be a monumental effort. It's going to be something that you would have to really think through and do yourself. You have to really roll a lot of deployment code yourself. Of course, Terraform's going to help with this kind of stuff, but there's only so far that it can do until you have to by yourself create shell scripts to run inside the server to do different mutations for front end and back end. And yeah, it's hard to keep databases consistent also, because imagine if you want to scale, you can basically only scale vertically, because if you were to horizontally scale like we have over here, you can see that the databases are actually two different databases. Now, how do you reconcile a certain user that's coming to your front end? Which server are they supposed to go to? Now you're supposed to create like a separate load balancer or something that'll kind of understand which database has that person's data. So it becomes a lot more complicated to scale horizontally with monolithic. And at that point, basically, you can only vertically scale with this. And another thing, like I mentioned over here, one server crash could basically end everything. Because imagine, like, and it's not really a hard to imagine possibility, because it has happened. Especially if your server load gets too high, it's going to crash. There is a possibility that your disk could get wiped. Everything is in one place, so it's easier to hack also, because once they have access to your front end, they're on the same server that holds your backend and your database. Although chances are low, it's still not impossible, and it could wipe your database, which will impact all of your users. And basically, yeah, this is perfect for when you really just want to do tests and see whether your application that you've made kind of works. And it's not at all a bad option to just run everything on a $5 VPS. It's pretty cheap. Costs are extremely predictable. It's not going to scale randomly like you would see with serverless, because they have this thing with horizontal scaling because of how standardized it is. They can just keep scaling your application, even like if you have like a DDoS attack. For a single server, it's just simply going to crash. But for a serverless application, it's just going to keep scaling until you get like a huge cost at the end of the month, and then you have to foot the bill, or you have to contact customer support or something like that. So that's why monolithic applications and $5 VPS is a perfect test ground. But if you want to build for production, this is not the way to go, which is why we finally will get to 3-tier applications. But yeah, this is monolithic. Let's go into 2-tier. So there are two different ways in which we would be doing 2 tiers. So a 2-tier application is basically where we're separating um, one of the components away from the other two components. So over here we have one which is going to be the front end and back end together, and then the database in a separate place. Or the front end in one place and back end and database in another place. This is less common, but it is there. There are examples of how it's being used, and I will get into this because the examples for this is kind of crazy. But yeah, let's go into this 2-tier. So uh, the cool thing about this is that, you know, your front end and back end are in one place. So the stateless parts of your application are going to be in one place. So you remember the shell scripts that we were talking about before, that you would have to create like, you know, particular things in your application, like in your deployment process, that would like replace it properly without hurting your database. Over here, it won't really be an issue. And especially if you have like a Next.js application where both your front end and back end are basically in the same application, this is like the way you want to go. It's basically going to be a 2-tier application. It's going to be on a single server. It becomes very easy to scale because it's together. So you just have to scale your server accordingly, and then you can scale your server differently. You can have a different scaling mechanism for both, and your server can now, your database server can actually be a managed database server, like an RDS or a Torso or a Superbase or whatever it might be. So this is a good thing. But there are a few cons, which is round trip time is slightly worse. It's kind of hard to say because what if this is in a completely different region compared to where the database server is? It's going to be hard to kind of scale that. But if you use something like Terso, you're going to have pretty good round trip time. But there is still a con to this, where front end and back end are still being deployed together. So you can't have a specific deployment strategy for your front end compared to your back end. And we'll see later on how that benefits us. But those are some of the things about this. But this can completely work completely fine in production. There's nothing wrong with this. But yeah, we cannot have specialized scaling, and this inherently will be more expensive than monolithic, because again, instead of deploying one server for an application, you're going to be deploying two servers, right? And then when you're increasing the number of servers, it's just going to like increase the it's just going to, as you can see, like you have now 3 servers instead of 2 servers if you want to handle more people. So it is more expensive. But yeah, stateless components are together. Deployment is pretty much more straightforward than that, and scaling is a lot easier. Now let's go into the ugly child of 2-tier, which is front end coming together and then back end and database together. Now where is this really being used? Round trip time is slightly better because again, you can think of it like this. It's not really a rule of thumb or even a guideline, to be honest, but it's something that maybe you can think of, that the round trip time between the front end and the back end is better than the round trip time between the back end and the database. It's not really especially true even if you're using something like a Redis database, but that's typically what you want to look at. But yeah, some examples of this is where people would deploy their front end, like their React app, on like an AWS Amplify or Vercel or Netlify. So at that point, their front end is basically zero cost, and all they have to do is just pay for a single server. So this could be like the front end serverless solution. But then you can still do two-tier also on Vercel depending on what kind of framework you're using. So it's framework dependent. If you're doing it this way for serverless, it can only be something like Next or Nuxt or SvelteKit or something like that. So this inherently will be cheaper than probably this. Depends on what use case you have. Then you have your backend API and database. So this would be kind of like your Python app interface with like a JSON file in your computer. So I've seen a lot of junior developers actually do this when they first started out. Like they've become really excited with using React, and they would just deploy it on Vercel because that's what they saw online. Then they would do a Python application and then some JSON files and then make some Spotify clone or whatever. But this is pretty much the worst thing you can possibly do to yourself because it takes the worst possible combinations of anything that you can do and makes it basically impossible to use for production. So this is something you want to stay away from, like with a 10-foot pole. So do not do this. Scaling is basically impossible. Database cannot be kept persistent easily, and deployment is extremely complicated for the reasons mentioned before. Now we come to three tier and why it is so goated with the sauce. All right. So this is where we have front end in one place, back end in one place, and database in another place. So you're keeping each component completely separate from each other. This is by far the thing, the scaling strategy or the software architecture that you definitely want to use when you're building your production based application. Because again, it's not like two tier where you have to like create a specialized kind of deployment. Like this is like each one has its own kind of server. So you just have to think, okay, what is the best way for me to deploy my front end? What is the best way for me to deploy my back end? What is the best way for me to deploy my database? And because of that, you can have a better pricing model. What is the best kind of server for a database? What is the best kind of server for a back end and whatnot? And gives you a lot more flexibility. So you can have something like a specialized scaling. So the front end can be on something like an AWS Amplify or a Netlify or something like that. It could be on a separate place because it's meant for that, right? So you can have your front end in that place, then you can have your back end in like many different things. You can have it in Beanstalk, you can have it in App Runner, which is a pretty cool alternative, and you can have it on any kind of thing, like even GCP Cloud Run if you want, AWS Lambda. You can put it in any kind of place, and you can actually strategize the way that you want to scale it. You can make all of these separate components like completely edge rendered if you want to. Database can be on like Terso, which is completely edge serverless, and Lambda at edge, and this by default, if it's served over a CDN and completely stateless, this can also be there. So that's the benefit of having that kind of a scaling, right? So you can have the specialized scaling. Each component can scale differently. Each component can use separate resources, right? So the example that I gave, front end AWS Amplify, back in AWS App Runner, database can be RDS, DynamoDB, S3 SQLite. Now you have options, dude. You can think of how you want to do it. Deployment is easier to understand because you don't have to do any fancy footwork in order to not. It's not fragile anymore. Everything has its own place. It's easier to understand. Cost is typically lesser depending on how you're planning on doing it. It can also be slightly more, but in the end, it's pretty much worth it, especially because of other certain reasons. You are actually less susceptible to crashes because now imagine if you have a DDoS attack, it's gonna only impact your front end. Yes, you might have a back end, like if it's making requests to the back end, it's going to impact back end as well. But you can make it so that this rate limits as well. So you can do that also on a monolith. But the thing is that because the backend's on the same server as the front end, if the front end crashes, the entire server crashes. So there's no benefit. But because it's all on separate servers, the backend can be completely isolated now from that particular thing. Even like in the good version of the two-tier application, right? It is gonna fail in a DDoS attack. This is less susceptible to it. You can do like a rate limit and not have it crash. But this is like this is the best of all of them. So, and security can be a lot better implemented with this, because again, you're not having certain things at the same server. It's all in different places. So it's going to be harder to kind of like pinpoint where the backend server is or where the database is. So security is a lot better with 3-tier. Now, preparing the initial deployment process or the continuous deployment, the script, the Terraform, Pulumi, whatever you want to use, that becomes a little bit more complex, because you have to take that time to think of the optimal strategy for you to deploy these certain applications. But because there are so many resources for these particular components, like how I mentioned before, front end has its own thing, back end has its own dedicated servers. There's a lot more, you know, there's a lot more easier options. There's a lot less mental overhead when it comes to thinking about these things. Round trip will be worse. If all the components are in the same region, it's going to be better. But there's a chance where if you want like a cheaper database, it might be in a region where you can't host your server, because that'll be more expensive. So round trip time is going to be worse than having it in literally the same server. But it is, I would say, in my opinion, it is a risk that you should be willing to take, because I think it's a great architecture to have everything in its own server and just think of it in a different deployment process. It's really good. I've used it with many clients. 3-tier is so straightforward, and you can actually create a standardized sort of deployment process where you can just carry it over from one client to another when you're building an entire full stack application. It's going to be great, right? Because you have to also remember, not everyone is going to work with your stack. Especially me, when I was working as a consultant, everyone had their own kind of tech stack, and it wouldn't be Next.js all the time, or Nuxt.js or something like that. So front end would be React, back end would be Python, database would be MySQL or Postgres. These are things that you typically cannot really keep in a monolithic or a 2-tier application. You would have to use something like a 3-tier to replicate a 2-tier for different kinds of back-end solutions and front-end solutions and database solutions is extremely difficult. It cannot really be replicated. For 3-tier, it's definitely possible, because the base is the deployment, right? And then what you put on top of that is basically kind of irrelevant, especially if you're using Docker, right? Because you're just gonna put a Docker image into it, and then the 3-tier is just gonna package it up and put it in properly. So it becomes a lot more straightforward once you have created that deployment process with 3-tier. Monitoring is a lot better, especially with 3-tier, and building on top of this, like creating Redis queues, sorry, not Redis queues, but a Redis cache or a RabbitMQ queuing strategy, or a pub sub, or whatever it might be. It becomes a lot more simpler with this, because you're following the same paradigm where you're spinning up a separate server for those services as well. Um, and this is what people do with a lot of these self-hosted things like trigger.dev or ingest or whatever these different kind of queues that do exist right now on the market. So 3-tier is by far the best, and this is basically an outline of what software architecture is and why 3-tier is basically the best. And thanks guys for watching. This is my first video, so I hope you guys enjoyed it. See you next time.